Yes, yes it is. Okay, last day we were looking at strong and weak, no, strong and strong titration curves. They start very low if you're titration into acid. They go up very steeply. I probably made this one a little too shallow. It should be a little bit more steep. And then you have excess base. Has a narrow range. And lots of indicators will work because they'll fit within that narrow range. And we see a couple of examples there, starting off with an acid or starting off with a base. Also got another larger one for you to see, just so you don't see my own drawings, which are pathetic at times. I did have a university prof sit down with me and tell me there are certain areas of biology that perhaps I shouldn't go into because my drawing skills were so bad.
Oh my god.
Areas of biology, even taking a picture, does not show things like texture, it just shows color. So there are still drawing techniques if you're out in the wild discovering and drawing that you are still expected to be able to do. And my artistic skills are not zero, but they're close to zero.
How's the drawing going to be more precise?
Because you can add stylized textures in a way that a picture won't pick up. It just shows you color.
Can
Like feathering and other stuff.
Can AI do it now?
AI?
Yeah.
Like AI, you could incorporate AI to do it for you.
AI would just make stuff up.
No,
That would be awesome.
Told no, but based on,
this is text.
based on like what's there, it'll just make a drawing for you.
Yeah, that it'll also make stuff up.
No.
You get like a 3D
Yeah.
scan. Just get a 3D scan.
I've gone to AI and said, I'm doing this essay. I would like 3 wrong answers as examples. And it gives me 3 answers, 2 of which are wrong, but so wrong as in it's weird, and then 1 that's actually right.
No, because if you're asking for a wrong answer, you're asking for double negative. What is
No, one of them it kind of, I re-asked it, phrased it, it did a semi-decent job. But anyway, next one we're doing weak acid. I don't want to be distracted because we have lots to do. Haha.
How come we're doing so many units at a time?
What?
We haven't had a quiz in forever.
Yeah.
I'm not trying to.
Get busy. Go.
Where's the
No.
LP?
You already got it.
No, I didn't.
This isn't new. This is from last day. Weren't you here?
No.
Lies.
It doesn't exist.
I don't think I was here.
Here, Felix.
Yeah,
Felix.
yeah.
We just have to go grab it. It's right there on bed. Okay. We are now going to do a weak acid. Felix, what's your favorite weak acid?
NaOH.
That is the strong base, and I'm going to pretend I asked you for that. And someone else said HF, so well done. If we are doing a weak acid and a strong base, and here's our Erlenmeyer flask, and there's our burette with the little thing on the side. We're putting stuff in. This is clear because we haven't done it, meet the indicator portion yet. Where's the weak acid and where's the strong base?
Weak acid in the flask.
In the flask. So this is the weak acid. Ooh! Clever use of terms. Yes. And this is the strong base. We always put the weak, whether it's a weak acid or weak base, in the flask. You're always titrating against something strong. We never do a titration with weak and weak. You won't see a shift in equilibrium. You won't get a nice titration curve. You want it to affect an equilibrium. You get the best kind of curve that way. And so you always want the weak thing in the flask.
What happens if you do both strong? Will it just react like?
Oh, both strong is what we just did.
Yeah, but like, I mean, in the titration, like, it'll still work, right?
Oh, yes. Yeah. And that's, you, actually, did we do that in that one? Did we have HCl? I don't think we did one with HCl. But you get a really nice titration curve. With these ones, you don't get quite as nice a titration curve. So as we're going to draw this, weak acid, strong base, we are going, now, will it start low or high? Is it going to start at 7, above 7, below 7? What's it?
Below 7.
Below 7. Way down here in the bottom, a little higher.
Higher.
A little higher. It's a weak acid. So unlike strong acid starting, it's not going to start way down here. And you're also going to get this little curve that looks like that. As soon as that strong base hits it, kind of shocks the equilibrium, and you get a shift right away. And then it sort of tapers out like this. That should be more smooth. And then you get the titration curve. Pardon?
Why it drops? Is this something to do with like what we did in like KVAT B?
When you start off with a weak acid, where's most of the stuff? On the reactants. Because it has a Ka, so most of it's here, and a tiny bit of it is there. And as soon as you add a little bit of base, you use that up, and it starts shifting a bunch of stuff over there. And now you've got a bit of stuff on both sides, and the equilibrium doesn't react as quickly. Like you get stuff, and so it doesn't have as much to move. So you get a rapid change at the beginning because there's almost nothing here, but it just gives you that little bit of curve. It's not important other than to notice it. If you see that, you know you're dealing with a weak acid.
Wait, but my question is, isn't that like something we learned back in like first term? Where like for equilibriums there's, and when you add something there's a spike, and that's the case for
because that, with the reaction rate, it is not due to the spike, because the spike goes up and then goes back,
Oh,
right? Like you're talking about like the rate where it goes like this and then comes back down.
yeah.
This is, if you stopped it there, it would stay there. So it's not that, because you're adding it dropwise. But no, that's actually a good relation back. I mean, conceptually it works, but don't remember that. And then it will go like this again. You have, here is your pH. Let's say this is a pH of 7, and your equivalence point is above 7. Equivalence point above 7. Why, when you titrate a weak acid with a strong base, would your equivalence point be above 7? Weak acid, strong base.
Let's see.
Yeah. Initial pH is higher. I'm just adding that in. Oh, I moved this. Don't like that. Now it's too far away, but we'll just do that. Initial pH is high. Weak acid, strong base. Why is your equivalence point above 7? Because you're adding
A strong base.
You are adding a strong base. Has nothing to do with the strong base. So the equivalence point is basic, but it actually doesn't have anything to do with the strong base. That is often the mnemonic that students use.
Is it like the KW, so it'll be slightly more?
It does have something to do with the KW. I suspect, though, that line of reasoning won't help. So don't think of KW, I think.
What is your new Philip?
Yep.
What's the equivalence point again?
When you're halfway in the titration. So right in the middle of the color change, or right when the stoichiometric ratios are met.
Then
So
could it-
all of the acid has reacted with all of the base.
Could it have to do because there's like observing like extra ions?
It does have to do with extra ions.
Well,
Because they're like taking up space or something.
No, it's not because they're taking up space, but it is because they're doing something.
is it because you use all of it and there's not enough to react with?
No, we've used it's a strong base, so it's a one-way arrow. So we have weak acid plus NaOH.
Because it creates spectator ions.
Where are the spectator ions? Where and there's a spectator ion?
The Na.
The Na is a spectator ion, so that's not going to do anything. So that's why the strong base is doing. But what's a spectator ion to a weak acid?
A weak base.
A weak base. So we are creating a weak base. So even if we've reacted everything in the solution, all the acid and all the base are gone, all we did is create a solution that is basic.
So if it was a strong acid and a weak base, then it would be the opposite?
Yeah.
Okay.
And we'll do that case next. Do you want me to keep that on? That was just scratch work.
Wait, what is it? What is that thing?
And we'll hold it. Am I
Purple?
recording?
It
It's like WA plus NKO what?
NaOH.
Oh, NaOH.
Yeah, I'm streaming.
What's WA? What is that?
Weak acid.
Oh. Okay.
That was NaOH. I crossed it off because it's the Na was a spectator on. So weak acid at equivalence point or stoic point in conjugate weak base. I continued the sentence there. Therefore, pH greater than 7. So even after it's reacted, it's because its partner in crime, its conjugate, is basic. Now, part of this KBAT section, we have you do net ionic equations with these. We review it later, but I'm also going to do it now because it'll get you used to it in this context. So by the time we do it in a couple pages, it should be easy. Let's do this one.
Can you calculate it so that you get it?
Pardon?
Can you calculate it so you get a solution that's equal to a pH of 7 when you add a weak acid and a strong base?
You will get a pH equivalent to 7 if your conjugate base is so weak it doesn't do anything.
From where?
And that would be
What if
a
you just-
strong acid.
What if you just
Hold it.
leave?
That would be a spectator.
Those are so
So, for example, this is a one I have to do here. Let's say we have, if you want it to be near 7, then the conjugate base has to be extremely weak. The weakest conjugate base comes from a strong acid. So this extremely strong, this is like the Ka of 10 to the minus 2. Most stuff is still on the HA side, but its conjugate base will be 10 to the minus 12.
No, what if you like don't fully react all of the weak acid,
Then you're not at the equivalence point.
but then you'd have like some weak acid and
Yeah.
some weak base, and then you
Yeah,
could
you're in the middle of the reaction. The reason we care is because if you're above 7, take out your data tables, turn to the indicators. What indicator would be good for this reaction? Because we're going to be above 7, and maybe this is like 9 or 10, so there's a few indicators that would work. But anything in that straightish line.
phenol red.
Phenol red. Any other ones? Can I? Whoa, you B word, my roast. Someone was having a stroke. Okay, so what did you say? Phenol red? Phenol red is down here. So there's phenol red. Maybe, but we kind of want it as close to here as possible.
Yeah, but we don't know what that is.
It's above 7.
Yeah, but
So-
phenol red also goes above 7.
Why not? The color change starts below 7. So why not pick like thymol blue? Thymol blue would probably hit right in that range.
Wouldn't phenol red be better?
Phenol red, 6.6 to 8.0. Yeah, that could probably work because it will start right about
That's what-
here-ish.
Isn't that
That's what I just said. Yeah.
It's okay, but it's not the best.
Isn't that better than, because 7.6 is like the end of it?
Well, this means that it's going to be there. It's not even going to hit the equivalence point.
Well, we don't
Well, that's
know
what-
what the
that's
equivalence
what-
point is.
that's
We know
what
that's
Thymol
above
blue
7.
does.
I'm-
He said thymol.
Oh,
No,
thymol
okay,
blue.
fine. No, that's 9. There. Whoops. It's 9.
Okay,
Now it doesn't work. Ha ha. I can
Now
just
use
change.
Phenolphthalein would be the best for it, cause it's right in the middle.
What?
Wouldn't phenolphthalein be better, cause it's,
Phenolphthalein would be great. That'd work.
yeah.
I have, if you turn a couple pages, I have a couple of examples of that. So like, do you have methyl red on here? Where's methyl? Where is it?
The six.
Third down, second box.
Third down, second.
Like third down in the second box.
Oh, there it is. 4.8 to 6. So to put one, methyl red would really not work. You probably missed the entire thing entirely. I just repeated myself. And you wanted to use, what did you say? Phenol red? Phenol red, let's use, because this has real data, 6.6. So that would start here and go to 8. So even though it doesn't hit the equivalence point, the amount of error in that's still going to be pretty low. You'd probably actually, honestly, yeah, you get away with it. Phenolphthalein would probably be perfect, and phenolphthalein is plentiful and cheap. But any of these, methyl red won't work. Methyl violet, thymol blue,
How do you
orange
make
4,
phenolphthalein?
all those things. Pardon?
How do you make phenolphthalein?
I have no idea. I don't know where they get it from. I only learned last night where they got thymol blue from.
Where?
Where?
A plant.
Which plant?
I don't know. It's a plant in China. They grow it in huge fields, and then they take all the leaves, they put it in a giant pot, and then like they react it with lye and calcium stone and a bunch of different products. When they take it out, it's just this blue gunk. And then they purify it and do more reactions and purify it, and they use it to dye clothing. And I was like, oh, that's fantastic.
Can we dye clothes with phenolphthalein?
Oh yeah, absolutely. Yeah. Most of the indicators were first known as dyes. They're just dyes that change color based on the pH of the solution.
Sorry, can I Google where we get phenolphthalein from?
Okay. But I am going to continue here. So we want to pick indicator with equivalence point above 7, and I'm going to ask you to write the net ionic equation. Give net ionic equation for HF plus NaOH, which is the one we just had. Goes to. They're all one-way arrows. Let's do something odd, like Na2HPO4 plus, let's do KOH. Sodium gets all the action. Potassium needs something too. And let's do something with a lot of hydrogens, triprotic, H3PO4 plus, let's do a really,
HPO4 you said?
ooh, lithium. Shout out to the drug, we don't know why it works.
What does that mean, Mr. Neutral?
Lithium is used to treat some conditions. Pardon?
Is it like bipolar disorder?
Yeah. And we have no idea why it works.
Phenolphthalein was invented in 1871 in Germany for dyeing clothes, and it's just mixing a bunch of chemicals. Just a bunch of
It's just a bunch of chemicals.
Yeah, phenol, phthalic, anhydride, sulfuric acid, zinc.
Oh, so it's an artificial chemical,
Oh yeah,
straight.
just a bunch of things, but in 1871 they
Yeah.
used it for clothes.
When I was in school, this had stopped, but my professors remembered when they were taking chemistry, it was highly recommended you learn some German. Because a lot of the early papers are all in German. German was sort of the early area of chemistry, as Canadians found out. And got really mad about.
Why would they get mad about that?
Pardon?
Why would they get mad about that?
They don't. It has a lot of side effects, but they will. It's still available for prescription because it's for a lot of. The DSM-4 and 5 is largely kept going by insurance companies because they need a diagnosis in order to provide insurance. A lot of mental health conditions are now recognized not as a condition but as a spectrum, and a lot of things can seem to overlap depending on what the neurochemistry is going on. And so you want to be able to label things. Sometimes nothing else works and they try lithium. I mean, we just found out that SSRIs might not work at all.
What's SSRI?
Serotonin uptake inhibitors, I believe.
Then you gotta get
Used
more
to treat
hydrophone.
some types of depression. Early days of quote unquote insane asylums in the 18th century, when people would die, they would do autopsies of the brain and see what chemicals were in there,
What's autopsy? Is it
Like when you-
dissecting the dead body. They would take brain tissue and then find out what types of chemicals were in it. And they found that people who were diagnosed with depression had low amounts of things like what they called at the time, I think it was triamine chemicals. Those turns out to be neurotransmitters, and those also turned out to be things like serotonin. And so the idea was, based on those studies, and further studies since then, we could actually directly test, was that we should increase the amount of serotonin. So one of the ways you could increase the amount, how many of you here are in biology AP? Have you done neurons yet? So you haven't done neurotransmitters yet?
That's not part of the
We did
curriculum.
that in anatomy and physics.
physiology.
Yeah, but you don't do it in AP biology? My God, you're anatomy. How many are in anatomy and physiology? So have you done neurons, the nervous system yet?
Yeah.
So you know, like neurotransmitters are released, they go to the other side, they excite the other side, signal continues. One of the ways that you can change how that, then those neurotransmitters have to be broken down, cleaved with an enzyme, or sucked back up. One of the ways you can make them act longer is inhibit the process to suck them back up. Then they stay in there, still doing their effect. Serotonin inhibitors were expected then to help depression based on that. Now they might absolutely do something because they are affecting serotonin. So there's a lot of things they might actually be doing, and maybe they do help it in some way. But we found out all of that old data was completely wrong. Group went back, reanalyzed all the things that this theory was based on, and found out that people who are diagnosed with depression actually do not necessarily have a decrease in serotonin. There might be some that do, but it is not a characteristic of depression. So we actually don't know then what we're treating. So that means we need to try different things. And that's why biochemistry is important.
Do people get like addicted to like whatever drug that decreases serotonin?
You can get addicted to almost anything, either physiologically or physically. But those are not traditionally drugs. I think they have other side effects that we're not traditionally worried about those. We tend to be worried about ones that deal with endorphins because those replace your happy chemicals.
Wait, which ones aren't addictive?
SSRIs are not considered hugely
That's
addictive.
not true.
No?
No, they're addictive.
Really?
I've gone into withdrawal. They're addictive.
Well, physically addictive. What I was interpreting that question as like, hey, can I buy some SSRIs? Like people aren't making them and selling them on street corners. There's a lot of drugs that are physically addictive, but doctors, I don't mean me, don't worry about people going out to seek them recreationally.
There's like some
Yeah.
of them.
Unlike, you know,
SSRIs
caffeine.
does get dependent on it. Like your body gets dependent on SSRIs.
Oh yeah.
But it doesn't on like
Okay. I will ask someone who's talking, so let's go with Dylan. Dylan, if you can give me the net ionic equation for HF plus NaOH.
The net ionic.
The net ionic equation.
The net ionic.
Net ionic equation.
Yeah.
Let's go. So excited.
Na is gone because
Oh.
react with water.
That is a brilliant thing that you said, so we just have that left.
Lovely. And now, can you help me?
No, just start reading. What is it? What's the first thing?
F.
No.
HF.
HF. That was brilliant. The reason is, this is a, what type of acid?
Weak acid. Weak acid.
No, just focus. What type of acid? Weak. So does it dissolve 100%? No, so it's not a spectator. So it doesn't separate, none of those are spectators, they stay. So weak acids and bases stay. So we have that, just aqueous by itself, just chilling. You already got rid of that, so then
And then there's kind of the OH left.
OH minus, yeah, goes to
Goes to F plus H2O.
F
Sorry,
plus,
F
F minus plus,
H2O.
yeah. So there's the net ionic equation. The only spectator in that was sodium. So weak acids, weak bases are not spectators or potatoes. Next one.
Can you explain weak acids, weak base are non-spectators?
Sure. If you have HCl, what kind of arrow do you have?
One.
One way, and they go 100% to this, right? So if you have HCl plus garbage goes to NaCl plus garbage.
So would K also, KOH
You
also
know,
be
well then let me just finish. You know that HCl aqueous doesn't exist. Because it goes 100%, this is actually H plus Cl minus. It always is, it always must be. This is completely soluble, so you always know that this is Na plus Cl minus. That means you would always be able to cancel. Right?
Cancel.
But if you have HF, that does not dissociate 100%. There is a thing that is just HF in solution.
Oh.
Right? So on this side, if there's F minus, it doesn't cancel. It's not the same thing on both sides.
Oh,
Does that make sense?
kind of.
Kind of. Taylor?
Would the K in the KOH also be a spectator?
So the K and the KOH, why don't you finish off that one?
Like, I was thinking it would be HPO4 plus OH. Would that be the right track or no?
HPO4 plus, yeah, you're just missing your charges.
Okay, so that would be minus 2 and minus, like minus
Yep.
1, yeah.
What kind of arrow?
1,
One way, because that's strong.
yeah.
Goes to?
PO4 3 minus plus H2O.
Perfect. Last one, volunteers? Dylan is volunteering for the last one?
Yeah, I am.
Are you?
I will.
Okay, go.
Okay. Cancel. No, we're not. Wait. Okay, just take everything.
Lithium is a.
Yeah, lithium's a spectator because it's connected to the OH.
Okay.
So basically, what we're gonna have is H3, PO4, no, not aqueous. Just keep it like that.
No, it's aqueous.
Oh.
All these are aqueous.
Okay.
Yeah.
It's aqueous.
Yeah, no, you're good.
Plus OH.
Yeah.
Minus
Oh, this is beautiful.
goes to H2PO4
Nope.
minus H4. No. I'm lying.
It's not H4, that was good. Yeah.
It's not H4.
Nope.
HPO4.
Nope.
But then it'd be H3O.
No. Wait, what?
H2O. So H2.
No. So
H-
I think you might have whispered something.
Is it just PO4 plus H2?
See, why would I guess that? H4O. Wait, what?
Okay, what kind of base is this?
2H2.
Strong. So let's pretend, you know,
They just have
when it's reacting with a weak base, right? Felix, or weak acid. Felix is HF. He's my weak acid. I'm a strong base. I'm just going to come and I'm going to take his candy. Because I'm strong. I can take his candy. He doesn't have any choice. One-way reaction. Does he get his candy back? No. However, if it's H3PO4, he has 3 candies. How many candies am I going to take? All of them. Those are all my candies. Because I'm a strong base. My candies.
So strong base can take
Takes
any amount.
all available.
But there's not enough OH though.
Yeah, there's none of it. So what do we have to do now?
Balance.
Balance. We have to say, oh, there must have been 3 candies. So he had to take it 3 times. And we got 3 waters. So balance. So you still get ratios. You need 3. So this is why if there was like an acid spill, like strong acid, I am not going to use, or not strong acid, let's say if I spilled some sodium hydroxide on the floor. It is a strong base. People are going to get damaged if they walk on it, if they get anything on their hands or feet, like that'd be terrible. I spilled some lye. I'm not going to use hydrochloric acid to clean it up, because if I use too much, I just now got strong acid on the floor. But if I use H3PO4, it will take 1/3 of the amount to neutralize it, And if there's leftover, it's just a weak acid. It won't do anything. If you have a strong acid spill or a strong base
You
spill,
just like take a bunch of H3PO4 and just like dump it on the floor.
yeah, just dump it on the floor. It'll all react and fizzle away until it's done, and then you just sweep up the powder. It's just H3PO4. It's fine. Well, not the powder. In this case, it'd be a liquid. In your kitchen, you have an acid spill or a base spill. You just use sodium bicarbonate, NaCl3. This will react as an acid if you put it in base, and it will react as a base if you put it in acid. And if you use too much, you just have baking soda, so it's not harmful. So the best thing to clean up a spill is with weak acids and bases, because they don't keep reacting.
What if you titrated it perfectly with HCl?
Oh, that works, yeah, if you added the right amount. But often if you're dealing with a spill, it's not in a nice clean container where you know exactly how much you have.
So why did it say you should put baking soda and lemon juice for toothpaste?
Oh, God. You can use baking soda for toothpaste. I've heard of that. If you use baking soda and any acid, you have failed fundamental chemistry.
I don't know, I've seen videos where it's like you mix.
I've seen tons of videos where they're cleaning something, they pour in a bunch of baking soda, then they pour in a bunch of vinegar, and they go, ooh, bubbles, and then they clean. They neutralized their cleaning product, and now they're working with basically water. It doesn't do it. Vinegar or baking soda to clean, not both. Now, where that comes from is that there is, just forgot the name. You use it to make things become more dense, not for them to rise.
Oh, baking soda?
No, it's the opposite of baking soda.
Baking powder?
No, it's not baking powder. Baking powder is baking soda with other stuff. No, it's it's the white blocks and it's got a little rooster on it.
Like the top. No.
Tartric acid,
Oh, tartar?
not tartar. I think I'll have to go double check it. If you react this with an acid, you end up making its ion is actually more powerful than its acid, and then you actually can do something. Anyway, tartric
No, it's not.
cream of tartar? No, I don't know.
Yeah, yeah.
I'm gonna go look it up to make sure, but I don't know. Okay, weak base, strong acid. Because you're distracting me. Stop that. Echelon, give me a weak base. What are you looking at? You're looking at your own. NaOH is a strong base.
Oh, right. Oh, weak base.
Weak base.
No, that's really strong.
That's really strong.
Yeah.
HCl.
H2O.
Okay, HCl just became a strong acid.
Yeah.
HSO3.
HSO3 would work. HSO3 minus? Sure. So, and you would probably make it NaHSO3 because you have a spectator there. Which is going to be the Erlenmeyer flask?
The weak in the bottom.
Acid.
The strong acid?
The acid's gonna be in the burette.
Goes straight down from B.
Which one's which?
The acid's gonna be in the burette.
Acid's going to be in here. The strong is always in the burette. The weak base is going to be there. You always put the weak in here.
Wait, did we do that in our titration lab?
The way the procedure was set up, yeah, your weak acid was always down here when you had NaOH up there.
No, but do we do like a strong acid versus a weak base?
No, we didn't compare them. You first made oxalic acid, which is a weak acid,
Okay.
and then you had your unknown NaOH in here, and you titrated it in until it changed color. But then you used your known NaOH and did a bunch of other acids. Yes?
We're only using like Na something. Can you just use like for a weak base? Can you just use I3O negative like as your weak base?
IO3 negative is that's not a strong acid, is it? I think I'm thinking I minus. That's a IO3 minus is a weak base. Yeah, you can do that. Do you want something without H there, basically? Well, why don't we make this mirror the previous one? If HF is a weak acid, what's the equivalent weak base?
What does that mean?
What's the conjugate to HF?
Just F minus.
F minus.
Yeah, so there's our weak base.
Wait, why didn't we pick the one that I said?
Oh, I'm going to use it down here.
Oh.
But it has an H in it, so I don't want to confuse anybody who's like playing along at home. Pardon?
What if we do H2O?
No, stop that. We're in water. That's just what it does in water.
So,
So you don't titrate water in water.
yeah.
Yeah.
But H2O is a weak.
H2O as an antiproduct can be an acid or a base, but all of these reactions take place in water, so you don't titrate water. Will the pH start high or low? Dylan, move one over. High or low? High. And will the equivalence point be above 7 or below 7?
Below.
Below. So we're going to get an initial downswing, then this, then that, and then this. So you get that wider range. Oh, did I label that in the earlier one? Label that on both. We get wider range. That's just true on both. As compared to the earlier one, it's quite narrow.
So what does the range represent?
The amount of the volume of acid added. So there is more error in this process when you're doing a weak one. So you really do want to hit the equivalence point. You get an equivalence point.
So we're actually doing NaHSO4 or HSO3, sorry.
Pardon?
We're actually doing NaHSO3.
No, we're doing F minus.
Oh,
And
this
why
is
is
on the
that
other.
in the thing?
I
It's a-
changed it.
Oh,
Okay.
Yeah. I mean, you could do it. It doesn't actually matter. Equivalent point less than 7.
Is this graphic also?
It starts not at the very top. We're not starting really high as if we're starting with a strong base. So initial pH less.
Wait, no, I think this is supposed to be going down.
Then strong base. Dylan? You're just really loud.
Sorry. I'm just confused because it goes down, then it like goes up, and then it goes down.
Yeah. So you get this.
Why is there so many bumps?
So you get this as an initial downswing.
Okay.
Just like
This is when you're adding like the acid.
when you
It's like
just
a
start
shot.
adding the acid.
Okay.
And over here, we had an initial upswing.
Okay,
So
you're
initial
adding
upswing, this, and then the equivalence point.
this. Yeah.
Here you get initial downswing, go along,
And then
equivalence
the
point.
equivalence point is when, like, for example, if
Halfway through not halfway, when the stoichiometric point is reached. So all of the
so when
acid
it
is
turns,
reacted with all of the
pink
base.
or whatever, like in the lab, when
Yeah,
it turns pink,
yeah.
is that point?
Well, it goes pink when the indicator changes color, which hopefully
Happens. Like,
is right at that point. Yeah.
Okay.
Drugs.
What kind of drugs?
Caffeines are drugs.
Oh. So they're just giving us all drugs.
Mr. Newfield,
Yeah.
would we ever be like judged on how accurate our graph is to,
I know,
like, if we just draw a titration curve, but then we just show that the equivalence point is below or above or at 0 or 7?
Right now, if I just said draw me a titration curve for a weak base, you'd have to, the kinds of things you should know, well, you'd have to have a strong acid. The equivalence points would be less than 7. You should have an initial downswing. But I'm not drawing the accuracy in that, like, you can see mine's a little floppy and not very good. But it should have a wider range. Like, if you made it like, and you went, whoa! I'm like, I can't see. Unless you labeled, this should have a wider range than normal. Your labeling can help a lot if you have messaging drawing. Obviously, I dealt with that a lot. And I would use labels to explain what I meant. But later on, we're going to be able to say, what should the equivalence point be? And you'll be able to calculate that. But right now, that would be kind of a complicated question. You'd be able to do it later. But right now, no. I don't think even we do that very often. But okay. Let's do the net ionic equation. Net ionic for NaF plus, what kind of strong base did we use? So acid plus HCl. And let's use your nope. HSO3, that was a good one. Nope. NaHSO3. Give me another strong acid other than HCl, because that's boring.
HI.
Hydro what? Chromic?
Bromic.
Bromic. HBr. And HI for the next one. And oh,
No.
NH3.
We should steer away. Wait, why did you scroll up?
Because Eshwan asked me to.
But Eshwan is like just not paying attention.
Eshwan, put away your phone.
My phone's right here.
I didn't even think it was there. I thought it was in your bag. Now I really am asking you to put away your phone. Hold it. Why are your laptops out? That would be the problem.
What?
You're not doing it, yeah? Laptops away. They're just distractions. Put them in your bag. They're just distractions.
Okay.
I'm assuming you're doing something because that's what I do in staff meetings.
Really?
I have real work to do in staff meetings. The things they're saying up at the front don't matter.
What do they usually say?
I don't know. I'm not listening.
Is that why you were skipping into the?
Well, I'm not listening to your talk.
Oh.
It's not important.
I have busy house things to take care
What
of.
was he doing? We need blackmail.
I'm literally doing work for work. I just, you know, Ms. Allen actually nailed it because old person who had that job never took attendance. Miss Allen takes attendance and then sends me an email of what happened in case I missed it and wishes and hopes that I'm okay. And then I feel really bad. So now I go 10 minutes early.
She does that to everyone. She does that to me
We
when I
ch-
missed assembly once. She was like, I really hope you're okay.
I changed how we hand out phones in the morning in Privet House so that I can now go on time. Yeah. Yeah. Which taught me that Ms. Allen is very effective. Okay, I'm going to ask 3 people in a second to do those.
What did you change the phone to?
I used to give them up with 8 and 8:10 because I'd show up late to the staff meeting and it starts at 8:15.
Now it's 7:58.
Now I get to end them up with 7:15, 8, so I have enough time to get ready and get to the staff meeting by 8:05. Yeah.
Literally, you can just grab your phone once you get out. Yeah.
Oh, I shut them. So if you're not done on time, if you're not up on time, you don't get your phone. Why should we reward you for being lazy?
See, if you wake up early, though, you can get your phone.
Yeah.
Then kids can take them in the middle of the night.
That's okay.
What?
Kids can wake up and just take them whenever.
They're locked in my office.
Or do
Yeah.
No way.
Do you not lock them?
No.
They just
Where are they?
That's the day.
What house are you in? What kind of chaos is this?
But we just trust our grade 9s because we don't think it's prison or anything.
Hold it. You trust your grade 9s?
Yeah.
What house are you in?
Little.
Oh, that makes sense.
Not everyone has that. Yeah,
Mr. Duke felt like
We don't trust our grade 9s though.
No, our grade 10's way too
Like little rolling cards.
Okay.
Oh, can I do one?
People will come steal them back. Like what?
Felix, go for the first one.
Okay, it's gonna be.
What's the spectator?
The spectator's ended.
There, we get rid of that. Keep going.
Is there another spectator?
No. Just start. What is it?
Okay, it's gonna be F plus
F without a charge is just a swear word.
F minus.
There we go.
And then it's gonna be F minus plus OH. Oh no, HCl. And it's gonna go to HF Cl minus.
What?
Doesn't it go the other way? Or, sorry, no, never mind.
Cl minus.
Can anybody see another spectator?
CL minus.
CL minus. This dissociates 100%, so that doesn't actually exist as an
Well,
aqueous
you told
solution.
me that there weren't another spectators.
Well, I didn't want you to lose confidence
Is it
partway
just
through.
HF?
So it's just F minus plus H plus goes to HF.
That's so easy. Let me do the last one.
Oh, you want to volunteer for sure?
Okay, it's gonna be NH3 plus I, or plus HI, sorry. And that goes to
Wouldn't it just be
Taylor. What
Go,
did you
Taylor.
say?
NH4.
NH4
plus I minus.
I minus is also better.
I minus is also a spectator.
Yeah. So remove it from the.
Remember, strong acids dissociate, so if there's anything on this side that also dissociates, they're going to cancel out.
This is weak base and strong acid.
Yeah. So we have the weak base. It takes the donated proton from the strong acid, and a strong acid is always just H plus ultimately, and it makes the equivalent.
Oh.
So, Eshwan, this one.
Oh,
HSO3
plus H, and then that's gonna go to H2SO3.
Excellent. Something wrong with these?
H is plus 2.
No. H is plus.
Oh, just plus, yeah. H plus.
Oh my goodness.
And HSO3 would be, you took one sodium off of it, so it would be minus. Dylan? Sophia? Dylan.
They're
Dylan, come
really
there.
distracting.
Do I need to be here longer? Is this good?
Yeah, it's good.
We already discussed this. You got to pick the right indicator. So for this one, what kind of indicator would be good? With an equivalence point less than 7.
Methyl red.
Good indicators. Oh God, I can't spell. Methyl red.
Chlorophenol red.
Yeah. Methyl red, chlorophenol red.
What about methyl violet?
Methyl violet. That's now that methyl violet would be doing a change in here. So that would be bad.
Wait, what?
Bad.
That works.
How would that measure the change in there? It's 0 to 1.6, no?
Yeah. This is starting at a hold it.
That's pH.
That's the pH. It would be doing down here.
Yeah.
Yeah. So that would be bad. Sorry.
Why is
I was like,
Yeah, I put it in the wrong spot.
it just too extreme?
It's too extreme. You're way off the equivalence point.
Well, you can just change the equivalence point.
No. Your equivalence point is whatever weak acid you're doing. It's probably not way down here. You don't have a curve like that. It will be up here somewhere. For a really nice straight curve that has a very high start and a very low start, strong acid, strong base. If you're weaker, they're going to be more in. They're going to have a wider range, and you're going to be, if in this case, weak base below pH 7, but not all the way to the bottom.
So methyl violet is for like strong acid, strong base.
You could, yeah. Methyl violet is most often used to detect, is this solution really acidic? It's not often used for titration.
Oh.
Yeah. It's one of the colors in the universal indicator. So it tells you like, oh my God, this is acidic.
Oh.
Yeah. And this graph is to illustrate that. If you have an equivalence point here, then phenolphthalein is a good one to pick. If you're now above, you have, in this particular case, because it's labeled in the bottom, weak acid, strong base, then you're going to be above 7, and things like methyl red aren't going to work. And also for illustration purposes, do not yawn loudly,
This
make
is
you
so
depressed.
boring.
Relatable.
So weird and confusing.
I'm going to stab you with the bluntest object I can find. This illustrates, you can see different weak acids with different Kas. So when you get something that's strong, you don't have that initial upswing. There's very little one there, but then you see a bit of one there, quite a bit there, quite a bit there, quite a bit there. And so that is how you reckon, one of the ways you recognize you're dealing with a weak. Notice that right in the middle,
Is where
this is the equivalence point here for all of them, there, 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 there. But this is the point in which their Ka equals the concentration of HCO plus. If they were indicators, that would be the part in which they change color. And sometimes you're titrating an actual indicator. That's the other one in which you have a weak base. In this case, what is the weak base? NH3. And methyl red in this one works, whereas in that one it did not, because your equivalence point is now below 7.
Oh, so depending, are the colors depending on where the equivalence point is?
Pardon?
Like where the equivalence point is like what the color will be.
You want to pick the color that matches the equivalence point.
Okay.
So that's why you have ones where you see the range, and if you know it's going to be below 7, then you need to pick one that's going to be
And
below
it should
7.
be like in the middle of the range, right?
Yeah.
Okay.
This is just to give you, I didn't want to draw this. It's a polyprotic acid. This is the equivalent of an H2X. So you get a titration, you get an equivalence point, it slopes off, and you get another equivalence point. So here, you have H2A. Then here, you have HA minus. So right here, 100%, so above this, HA minus, all of it. And then here, we're down to A minus. And so polyprotic acids, you could have H3PO4, will have 3 equivalence points, one for each hydrogen.
Do we ever need to deal with polyprotic acid?
Yes.
Polyprotic.
I wouldn't mention it if it didn't come up occasionally. And they exist.
That's like
Why'd you
way
point at me
too
when you said
difficult
that?
for us.
I said they exist. I'm like pointing at Eric who asked the question. You're just in the way. Friendly fire.
You're a poly.
Yes? Luca, question?
No, she does not.
Next question is for Luca.
No.
Excellent. Move on to this one. This is grade 11 review. This is just a titration. You did this because this is actually your lab. That's oxalic acid, titrated. You have a 10 milliliter sample. The concentration of NaOH turned out to be this in this particular one. I've given you your table already.
This is a rice table?
It's not a rice table. It's an old Chem 11 concentration volume moles table.
Never seen that.
NBC.
How many of you had Mr. Snow last year for Chem 11? How many of you had Ms. Carroll? I don't think Ms. Carroll used it. It's just a way of
Ms.
organizing
Carroll.
your...
I missed
Hey, I'm Miss Carroll.
This is just a way of organizing your data. N just means moles.
Why is it in N, not just?
Volume is liters. That's the...
Is that
What?
the proper way to do it?
Yeah, N means moles. If you are measuring a distance in meters, what is the symbol for distance? D, not M. Yeah.
What?
Velocity is equal to distance over time, not M over time, because the units can be different things. And C is concentration in moles per liter. This is a way of just organizing your data, so you can put the moles in, see what they are, do the stoichiometric ratio. It's a way of showing your work. If you haven't used it, you don't have to use it. You can use whatever you used last year. Ms. Carroll likes the formula ratio method, which I also use in addition to this. Perfectly fine. But get into small groups, no larger than 3, or at least 2. Find a spot on the board and do it on the board. Because you've been sitting too long and you're complaining. Complaining too hard. No, you don't. This is a brain break. You're going to use your brain in a different way.
You complain more when you make us stand.
Pardon?
You complain more when you make us stand.
I know, but it's also good for you. Mm. Here, Luke, are you okay standing? I know if you're using that today. There is the really tall chair. You are welcome to use at any time. You can.
Alright, Eric. Put this one up.
I'm standing up. You do not have it. Let's go. Tip top.
I have a marker.
It's just like if you made like a data table.
Dylan, Sophia, more writing, less talking. Oh, yeah. From this distance, I can't see from this distance. I can see you, but like small details go away. It just looks like you were flashing your teeth at me, to be honest. I will now do attendance.
That's
5
years you get married.
Who just talked about getting married?
Oh, nothing. It's a long, long story.
You're getting married?
No, none of us are getting married.
He's getting married.
Yeah, I'm getting married actually. Like this week.
Congratulations.
Thank you. I'm engaged. No, I'm not.
You're not
But someone
engaged.
did.
Balance
Engaged in
once.
No, I'm not.
I need to redo this. Now it's balanced, right? Pretty
Welcome to the ability to do things while you're dying.
cut me. Okay, that's
I
my
knew first.
Cancel out NA.
No, there's three.
Chloe, Luca, Felix, Nicholas, Taylor, Eric, and A is not here. Eshwin, Luce, Sophia.
Someone use that for.
Thank you for coming to class. Teddy, Dylan, Sabine, James. Nicholas, thank you for coming to class.
Of course.
This is what I'm thinking. I don't know about you.
Yeah, this is the correct pattern.
So when you put it in, kick the room.
What is the concentration of silica acid?
We balance concentration.
It's concentration.
It's like saying it's
1.27 grams per liter.
Three is concentration.
Yeah, actually got this.
Mr. Neufeld,
Yep.
we need check, please.
1 second. I'm just going to finish attendance.
How the hell is third drawing okay?
Who needs? We're missing an A. And
Well, that's our war.
That's it.
I declare war.
I'm speaking.
Officially declare
Okay.
war.
I will start looking at. Oh,
Okay, fine.
you need the whole reaction. Whole reaction.
Yeah, what are you shooting? Like the acid, like No, we gotta make a.
It's a strong base, so it will react with
Add.
everything.
It's gonna be like.
That makes sense. I was just going for it. Well, that should
No,
still.
we
This
gotta
is like
make
10.
anti-air.
This is the anti-air.
Nick and Eshwan,
Yes, sir.
don't forget science 10. Balancing is important.
Yes, sir.
We balance, I think.
See, now it does, now leave out like a bunch of like.
Teddy, you didn't finish the combo. Teddy.
Inferno towers.
Inferno towers. You put down Inferno towers.
Inferno towers. You're on the tower. Stop it. Stop it. Or you're dead. E-bar.
Oh no.
Pekka. Mini Pekka. Nick, go. Mini Pekka. Sparky. Sparky.
You zap spark.
Wait.
Another sort of power. You're dead.
No, no.
You're dead.
You got
You're
me with
dead.
skeletons.
You're dead.
You got me with
Scarmies. You're dead.
Like what? What are you even doing? Walking on what?
Whatever power.
We're dead.
Oh, they're dead. You're dead.
No, we're back in the fair. We're being useless.
No, man.
What's your
What's it 2 times this?
Draw.
Yeah, this is when we don't have our phone. That's why we don't.
No, I appreciate that.
And then I'm gonna scar me. No, I'm gonna put it in my mini board.
So divide by
Balancing. Why do you have HCO plus?
What? Oh,
This is an acid and a base.
Yeah, watch this.
Oh, it drops down.
So if you're gonna keep the sodium, that should be, like C2O4 can exist by itself.
Concentration is your.
Well, if you take 2 hydrogens off of C2O4, what's the strength? Negative 2, because you took 2 off. So what ion on the other side? Is this attached to it?
The way you fireball won't do it. Rocket.
Oh, the OH went into the water.
Yeah, but you guys are walking there.
So you make it so
No, you're gonna balance once you're done. Like, you don't balance, you take 2 hydrogens off of that, so now you make balance. You don't really need this, but just for sake of completeness. You know that H reacts to OH in water.
That makes no sense.
This is left over with -2. Now you can balance. You can use sodium to just go there. Because they're both plus one.
Sodium's at 7.
C2, C2O4.
Which one?
I'm not.
7447.
Because acid-base reactions are just a complicated version of a double replacement.
Okay, I thought we always cancel it.
Well, if you did cancel it out,
Yeah.
so you might as well use it. If you did cancel it out, then you would just take out the sodium.
can't use it.
If you're moving across the table, you're going from here to there.
No, but like.
Eric,
Don't
don't
fire multiplier.
do the answers, Eric.
I wanted to get this right.
Are you gonna need twice as much hydroxide or half as much hydroxide?
Whatever that number is.
Whatever this number is, how much of this are we going to need? Twice as much or half as much? Twice as much. So if you're going from here to there, what do you think? Divided by 2.
But this is what I got from just multiplying.
Yeah.
Like this is not times 2.
No, not, well, it is what it is. If you wanna go from there to there, what do you have to do? Divide by 2.
Okay, what the hell?
Oh, I appreciate that.
Little nonsense.
The student
started
should
fighting.
copy that
I
last
can't
slide.
copy that.
Put it up on my wall.
Not ever.
Clash Royale.
Yeah, we're playing Clash Royale.
Point
Why is it so long?
007.
Why is it so low?
Why is it so long? Why is it so like 2?
Stop being so negative all the time.
Where you
Look at
need?
his board. I don't
You're such a
get
downer.
What do you mean his board? Whose board?
We have different. Mr. Neufeld.
He
Yes?
literally said ours was right.
But then why is his answer different?
They're not.
Are they?
They are.
They're very different.
What? It didn't,
What?
it didn't put
Eric.
balance.
Did you not balance?
Yeah.
Wait, Mr. Neufeld.
Oh, no, you didn't
Yeah,
balance.
you didn't balance.
Oh, wait, he's backwards. He put it backwards.
Oh,
Ours
I've been
is
doing it,
backwards.
well, then I haven't balanced, yeah. So we're gonna need 2 that,
That's why.
and
Backwards. Still right.
No,
To
he,
that.
yeah, he hasn't
We're
finished
still
it.
goaded, Eric.
Yeah.
so what's this one?
the one we got right
Yeah, what is it? Give me the number.
0.724.
Molar. And then at some point, you would write below here that the concentration of H2C2O4 is equal to 0.724 molar. To pull it out of the table and let me know you know which of those numbers is right. All titrations have a U pattern. You figure out the moles, use the stoichiometric ratio, and then you figure out the concentration. You always have 2 pieces of data on one side, that's the area you get the moles from, 1 piece of data on the other side, that's that. And that's every titration ever. And it doesn't matter which way you're going. You never need the products except to make sure that you balance the equation properly. any reaction with a color change that relates two chemicals together can be used as a titration. So solubility can be done. If it has a precipitate that's colored that you can identify, redox you can see that can be done. So there's redox titrations. They're not just acid-base, but acid-base are the most common because they have indicators that are easy to get. Did anybody put milliliters in here and get like 1.4? No? Nobody? The reason I mention it is if you left it in milliliters and you multiply and then divide, you will still get the right answer because it's the ratio. Eshwan? If you use milliliters, you'll still end up with the right answer. You may not know why these are wrong or why anybody's like taking marks off. If you are taking moles per liter and multiplying by liters, you don't actually get moles. If you multiply by the milliliters, you actually get something called a millimole if you work out the units properly. But you end up, since you then multiply by the same mistake, you end up back at the same answer. But if you want to do that, just use the calculation method and just use the ratio. C1V1 or whatever works, and then the milliliters cancel out. But if you're showing your work this way, you need to put it in your proper units. Everybody's now saying that titration, or at least seen it once, done a lab on it. Excellent.
Why is the NA spectator ratio?
It is. I didn't ask you for an anionic. So, like, you don't have to put it in anionic for this. So, group. Dylan, what are you doing?
Sorry, it's not 10, but
I'm going to put you in a different group. Excellent. I want you to do the next question. I have not given you a table or any work. And hold it. Why did that not work? Dylan, you can join any group but Sophia's.
Where's Lucas?
In pairs, erase the old work, do the next question. Find your person.
This is the war that ends all
Oh, there we go. Bless up.
4, 7,
So productive. I stay productive. Look at that work. No, like you said,
Someone raised the war.
I got that's a flash game.
wars that end all war. Any questions are on the board?
So it's sodium sulfite. This is sulfite, it's sodium Na. And then HCl. And then it's just
Did you do both?
Yep.
Can we ignore the first results because it's so far off?
I want you to do what you think you should do.
And we shall ignore.
Oh, yeah, that one.
Okay, so then,
And then the concentration of the acid is 0.2.
That's so cool.
No, for mine, I never did that.
And then it gives us a bunch of volumes.
Mr. Newfeld, we take that. Who am I with?
Pardon?
Who am I with?
What?
The NA and the.
Felix. You're with Sophia.
I'm here.
But did you grab your partner?
No, it's fine. I didn't see.
No, I know. But then neither did Felix.
I did, I thought she saw us too.
As nobody was working beside you.
The NA and the chloride.
So you're thinking hog ride.
Oh my goodness.
Wait, what? Titration is produced as a result of
Eric, I think you got your formula.
concentration.
What?
What was that?
Sorry.
Because it gives us these 3 volumes. So I guess that would be like the product. But I don't know.
So they want
It's not the same.
the sodium chloride.
Oh, you couldn't make this. It's all the same.
Yeah, you don't know.
It's 120.
We'll average these volumes.
Yeah.
this is, I think, the volume concentration to every single
Distance over time. That's
Oh, see how in each of these things.
The volume is just the
Did you write distance over
No,
time?
I wrote it here because you said velocity.
Is it bounce? Yes, bounce.
No, me and Samir just wrote the same thing.
Oh, he wrote that on the.
He was spectating. No, we just
Oh, you were saying velocity. I should have said
The first 3 to be done win a prize,
Volume is distance.
Ew, they're not even.
which is old pop.
Half drink.
You want old
Yes,
pop?
yes. It is sugar
They're probably flat.
and no caffeine.
Give those to Mr.
Then
That's
what's
not
the point
true.
of
The
it?
Diet
If
Coke
there's-
has caffeine.
Okay, if there's no sugar, no
Caffeine
it's a bottle of-
free.
Okay, what the heck?
A bottle of chemicals.
Give it to Mr. Mr. Miller. He'll
Are you
use
sure
it
you're
in
doing
the
like
thing.
number 2?
Oh yeah, we
Experiment.
can dissolve stuff with this sugar.
But if you do, I need the bottle back.
What?
Why?
So you want us to drink it?
No, Science 10 does a rocket lab. I need extra bottles.
Oh.
Dump it.
Oh yeah, I remember the rocket lab we were attending. Yeah, I remember that. My rockets
Yo.
sucked.
Look at this.
I know, they were like, they were.
What's your answer?
Is this,
What's your answer? That is not right. That's not even
is
close.
this equation,
There is lots of things wrong in that whole thing.
isn't the NA spectator so you drop it?
Wait, can we play?
Okay, but that's not the problem.
I know how to play Clash Royale.
I know how to play
Okay, well the numbers are wrong because of that. But is this
I don't think you know what sodium sulfite is, first of all. Or hydrochloric acid. You're doing this question.
Because what are we supposed to use? Which titration?
Yes, make your best decision. There is only one right answer.
Plans,
No,
not Clash
no,
Royale.
they're playing out. I was saying
Oh God, I love the
These are all dead.
Yeah.
Wait, do I still get a prize for doing
Like, is that
the other question?
Like a
Remove
map.
all ads.
But I don't, like, I don't.
One year,
Oh, that's not for no.
Oh, what are they, the volume of?
Products?
That one was so critical.
0.07.
We already have a volume. What's that the volume of? But whatever it is, the unknown sodium sulfite. So that must be the volume of the other one, the hydrochloric acid.
I want to try my
Also, what's sulfite?
Let's write the.
It is SO3. What's its charge?
That's
-2.
-2. So how many sodiums would it have? So we reacted with hydrochloric acid.
Wait, why is this the volume of the? This is like, so do we subtract 10?
Nope, that's the volume. Remember when you pipette into the thing? That's that.
It will still.
Yeah.
These are all your burette measurements of the chemicals. Yeah. Your products also need work. What's the charge on SO3? Oh, fix your equation.
There's gotta be another thing.
No.
The HSO3.
CL
CL is a spectator.
And there's NA. There's two NAs.
Excellent.
It goes to HCl.
Whoa.
And
Now you're just getting happy. Now, ooh, now you're balancing.
There we go.
Lovely. Lovely.
H
Perfect.
Uh,
How many NAs would your SO3
Minus
have?
L.
3.
Well, this is
Okay,
a
let's
D
write the
lab.
given.
minus.
L. What is that?
I
Beyond.
can't
Yeah.
Where's Sophia go?
This is gay.
Yeah, we're not.
Wait, a D is
You
like
are,
right.
you have to see me for your answer, and you are definitely,
You did
definitely
not
not
even
done.
balance the
Not
equation.
done.
There needs to be
Not
multiplied by.
Your equation isn't balanced, you don't have the right equation.
You guys are probably wrong. We were
This
Just
should be
like-
like-
we are very wrong.
It's a strong acid,
Bad
right?
wrong.
So it will react with every possible place you can donate a
What is
hydrogen.
that?
No, I'm just
So you won't really get HSO3 minus as a product.
See, like this is just bad.
Can HSO3 also accept our hydrogen?
Yeah.
So what will be the next step?
Why did you give me the wrong number?
Plus NaCl.
Oh, your products need work. HSO3 minus is not a product.
I think so.
It doesn't even balance the way you have it.
It's this.
Oh, that works.
Close. I thought it was that. No, that was just.
But on my painting,
It
I
was.
just do this.
It was.
What's your answer?
Yeah, it was a painting. I like that.
You're good.
We got the poker. Oh yeah. Which one you
On the root beer right now.
It's not HSO4.
Okay, we're.
Sulfite is
I
SO3.
don't ever.
And HCl is a strong acid. It will donate a proton to anything
You know
that
what my dad
donates
says?
it, whether it wants
My
to or
dad's is
not.
different every time.
I'm not.
His is
really
like,
My dad's.
Why not? This is
I get like a kind of like. I'm convinced.
Very, very close. You fell for the classic error.
Still have everything. My dad's.
You
How glad
need
it's
your
right.
data.
so I should have taken the.
Is this yours?
What the hell? It's on the line.
Nope, look at the data right there. Is there anything
My
sus about the
signature is
data?
smiley face.
This one, yeah. So
Yeah.
I'm not taking that one.
You should have taken that
He
one.
said no. Take your data.
Oh, I didn't see what you did. Most people just average that and do calculation once. So I thought you were asking, should I take out my calculation of concentration or mole, something like that? And then you would average it. Yeah, so you would take out that.
Okay. So my house is really like, it goes to my house.
You're not gonna-
Yeah, it's so live.
Yeah. In math. It's like.
But who's-
Is there a George Warning? George Warning. There's someone named George Warning. I swear to God there is. You've said his name. George.
Hold it.
I think you're combining this.
Not everybody here's done. Dylan, what's yours?
No, because I remember someone being like, there's something warning.
What is your answer?
Bro, don't put this next to me. I like
Okay.
But there's a lot of hearts.
Stuff going on.
I haven't been told the answer.
It's
always 14.2. You were over there.
Yeah, where's that now?
Show me. Bring me over. No one.
Okay, so
That one's done. But that one's not done.
create
Okay, come here.
a
Felix.
table for
Yeah?
Go do yours. I need to see it on the board.
Copying my work
Nope.
down.
No copying. Go do the work. No. Let's go scared. Go do the work. Up on the board. See you do it. Echelon? That's 10 for doing something in class.
10 what?
10 push-ups.
Bro, wait, you know, no, he was spawn camping my room. I walked in wearing shoes and he capped me. He was spawn camping my room.
That's so many.
No, but.
Yeah, why are you sitting underneath the...
tutorial.
Wait, Luca, did I send you that video?
Yeah.
Wait, he does that. He
Can I show him?
What are games?
Yeah, just show me the video.
It's
Oh,
really
yeah.
cute.
And he'll be like, okay, down, and you have to go down, and then he'll walk away for like 10 minutes. And you have to hold it, and if you fall down, you go again.
How do you know?
Look at this, quick Dylan.
What, like, he'll be in the area, but he'll be doing something else. Like, he's still inside of you, so he just like watches you.
Oh yeah, no, I got a copy of that.
Yeah.
Like, that's crazy.
I did that
Did you
yesterday.
like put like a
So it's like
light
you're
over
just
you
planking,
or
but like
You should put, wait, just think about
Or like,
You should put cameras like, in the house.
What?
You should put cameras. Walking like a hidden camera.
Okay. Most people got there. Number one, if you are sodium sulfite as you're leaving, It is NA2 SO3.
Oh, yeah.
SO3 minus 2
That's what I
can accept 2 things. So you need a 2-to-1 ratio. Other than that, you should have eliminated one of your data points, the 16 whatever. That is not a good data point. Clearly they overshot that one, as you often did in your own lab, when the first one is one you should discard.
No, we are perfect at all times.
Some of you are. Some of you are.
Yeah,
If you did take some of the pop, I needed the bottles back. Don't wreck the bottles. We need them for science 10.
Oh yeah, like the rockets.
The rockets. Felix, if you could clean up the pop you spilled.
Felix, chug it right now.
There's paper towel in the lab. Just go grab some paper towel.
No way you drank. No.
Chug it, Felix. Ready? Go.
No, not in here.
I bet
Not in
you
here.
open it.
Do that outside. No. That was fun. I don't want it spilled.
The suspicion that.
The lab's locked.
I will unlock it.
I cannot go inside.
Not to your like all kinds of Eric, go, what's up? Can I cross the lab? Because you're crossing the lab too.
No, people are getting paper towels.
I just use
You're gonna help clean up here though.
But they really.
Grab paper towels. Help clean. You can only cross the lab if you get paper towels to help clean.
Okay, we'll do that.
There's a spray bottle over there. That's not the blue one. You can use that. The spray bottle over there. It's not the blue one. That would be perfect.
The yellow one?
Yeah. Thank you. Thank you for getting rid of the stuff in the bottle.
Now can we cross?
After you spray and wipe, sure.
Where do I spray and wipe?
Right there. There's
You have to get there, Eric. I did mine a little bit.
Here.
Felix is gonna.
We're Teddy Stowe.
There's like, oh. I mean, this is.
Why are you guys doing that? I don't know. It's too much work for crossing. Something you didn't even do.
Thank you.
Did you grade our test?
Where is it?
Mr. Nico?
Hmm?
Did you grade our test that we have?
Yeah, they're on zip grade. I forgot to hand them out this block though.
Oh, can you hand them out now?
You can grab them now, yeah. They should be in the truck. I just forgot. No, Steam. Forgot yours.
Wait, where does?
They're in there somewhere. Loose. It's on zip grade. I'd like you to come and see me at some point in time because the multiple choice was not done well. And I don't know in terms. I'd like to go over it with you, unless you go over it and go, oh, this is obvious. I was just having a bad day or something. Okay. Okay. Tomorrow should. Wednesday, yeah, tomorrow should be good.
I don't remember my zip grade code. It's not remember on my phone. But I know at least I got 3 points.
Oh. I didn't check my computer. This is 10.
Listen, I'm crossing the lab.
Sure.